Okay, so today we're starting quadratic formula. We're going to solve quadratic equations by using our quadratic formula. And the amazing thing about the quadratic formula, guys, is that it works on everything. It doesn't matter how nasty your quadratic is, the quadratic formula is going to work on it. Okay, so for example, we've got this problem solving 2x squared minus x minus 5 equals 0. I want to know, can we factor it? Do we have a GCF?
No.
No. So we've got to slide the 2 to see if we have magic numbers. And now we've got x squared minus x minus 10 equals 0. So are there factors of negative 10 that sum to negative 1? 1 and 10, 2 and 5. Doesn't work, right? No magic numbers, so we cannot factor it. That's a no. Okay, our requirements for completing the square is that our a value is 1 and that our b is even. Is our a 1?
Yes.
Look at it.
No, it's a 2.
Okay, so not 1. Is our b even? Okay, so it doesn't meet any of those requirements, so we can't complete the square. Now, before we do a whole bunch of work and try to find solutions that don't even exist, real solutions that don't even exist, let's make sure that this crosses the x-axis and actually has real solutions, okay? So we're going to put it in the calculator. Remember that the 0 comes from when we turn to the y equal to 0, right? So we're going to go to y equals, and we're going to put in 2x squared minus x minus 5. Go to your calculator and put that in. It should look like mine. Remember that this is always a way that you can check your solutions when you're solving, because you get a calculator on your test.
2 zeros.
Okay, 2 real zeros because you get 2 x-intercepts. So we're going to draw a quick sketch. Two real solutions. But we can't get them by factoring, and we can't get them by completing the square. Okay? We can't use ZPP because it's not already factored, and we can't square root because it has a bx term. You guys see that we've exhausted what we know?
Yeah.
So we need one more thing, something that works on everything. Cool? That's what we're going to do today. Okay, so when factoring and completing the square, completing, that was an extra syllable, the square don't work for us, we can solve quadratic equations using our quadratic formula, which looks like this. Now I know it looks a little cray-cray, but it's actually pretty easy to use. The requirements for using it are that we get our quadratic in standard form. Set equal to what? 0. So just like factoring, we need it in standard form equal to 0. So this is nothing new. This is our normal starting position. But if you don't have it in standard form set equal to 0, you're going to pick the wrong A, B, and C. You're going to plug in the wrong numbers, and it's going to mess up your whole thing, and you're going to get the whole problem wrong. Does that make sense? So this is like mission critical, right? Okay. All right, let's go. Let's practice. Okay, so our first step is going to be that we actually have to get it in standard form equal to 0. Okay, so here, I'm going to write that as ax squared plus, sorry if you already wrote it, ax squared plus bx plus c equals 0. It's the same thing, but I want to use the letters. I changed my mind. So how do I get rid of this plus 5 on the wrong side?
You make it a negative on
Yeah.
the other side.
Subtract it over. So I'll have x squared plus 4x minus 5 equals 0. Now I have standard form equal to 0. My next step is that I have to find my a, b, and c. Okay, so what is my a? What's the coefficient in front of x squared?
1.
1. What's b?
4,
Okay, and c?
5, negative 5.
Ooh, negative 5. Good catch. Double check your signs before you start, and you will save yourself from a world of difficulty and frustration. Yes?
It looks like you need to complete the square.
What?
It looks like you need to complete the square.
On this one, you could complete the square. This one is also factorable. We're going to do some with really nice numbers today, and we're going to save the gnarly ones for Monday. After we already get some practice plugging everything in and doing some simplifying, we'll save the gnarly ones for day 2. We're going to do the sweet, nice ones today. Sound good?
Yep.
Okay, we're going to dip a toe in the water first. Okay. So now we just have to plug everything in. Okay, so these are the x's that make y 0. That make y equals 0. So these are our x-intercepts. Yep. Okay, so now we're going to plug in our a, b, and c. Plug them in. So I just follow the instructions. X equals, okay, if my b is 4, what is the opposite of my b? Negative 4. So I'm going to put in a negative 4. Then I'm going to say plus or minus. I'm going to draw a great big square root. Okay, this is really important. When you put in your b squared, please put it inside parentheses squared. I will tell you why on the second one. Right now we're just going to do it. So that's 4 squared, okay, minus 4 times your a times your b. My a is 1, my b is negative 5. Okay, and then this is the part that everybody forgets. The whole thing over 2 times your a. Now, I'm not going to lie, I've been doing this for a long time, and that still kind of makes me want to cry. The nice thing about this is that whole part under the radical, your calculator will simplify it for you. So this whole part is going in your calculator. Okay, get your calculator. Quit out of quit mode. Second mode will take you to your home screen. So we're going to square the 4, put it in your parentheses and square it. Minus 4, open parentheses, 1, open parentheses, negative, was it 5? Thank you. Make sure yours looks like mine. Okay, and then enter, and you should get 36 if you did it right. Okay, so under the radical, we're just going to put a cute little 36, which is nice because 36 we know is a perfect square. So let me raise this up. We got x equals the opposite of 4 plus or minus the square root of 36 The whole thing, 2 times 1 is just 2, over 2. It's already looking less scary. Do we know what the square root of 36 is? Yeah, it's 6. Okay. Now remember that this is a quadratic and we have to allow it to cross the x-axis twice if it wants to. So we're going to have 2 different solutions. The first one is when negative 4 plus 6 is divided by 2. Negative 4 plus 6 divided by 2. And the second one is negative 4 minus 6 divided by 2. Are you seeing where I'm getting the plus and minus? From that right there? Okay. So now we just have to simplify. So what's negative 4 plus 6? 2. What's 2 divided by 2?
1.
Perfect. Negative 4 minus 6? Negative, 10. Negative 10. Negative 10 divided by 2?
-5.
Negative 5. Okay, these are the x's that make y 0, so they go in our curly brackets. That's it. That ain't bad. Okay. Okay, do we have standard form set equal to 0?
No.
No, so we're going to have to subtract away the 2. And now we'll get 3x squared minus 5x minus 2 equals 0. Okay, what's our a?
3.
3. Oops. What's our b?
-5.
Negative 5. And the c is
-2.
negative 2. Okay, now we get to plug them in. X equals, here, I forgot to give you something. Equals the opposite of our b. If our b is already negative, what is the opposite of a negative b? A positive 5. Okay, plus or minus a great big square root. Okay, now my b is still negative 5, so I'm going to put it in parentheses and square it. Minus 4 times my a times my c. The whole thing over 2 times my a. Okay, it's time for a little baby rant. You ready? What is negative 5 in parentheses squared? A negative times a negative makes a positive 25, because you're doing this. Whoops, not 2. Negative 5 times negative 5 is a positive 25. Okay, so that's what should happen. That's what we want, because we want to square the whole b, even the negative part of it. Okay, what happens if we put in the calculator negative 5 and square only the 5? What do we get? We get a negative 25. Do you see how if your calculator thinks you want this, it would mess up your world? Okay, because you're supposed to get that, and if you get this, you're likely going to think you have no solutions when you actually do. No real solutions when you actually do. So be careful. Don't write it like that. Make sure you use parentheses and square it. Okay, rant over. Let's put this in the calculator. This is going in the calculator. Okay, so we're going to do open parentheses, negative 5, close them, square it, minus 4, open parentheses, 3, close them, open, is it negative 2?
Yes.
Thank you. 49, which is another perfect square. Yay! Okay, so this whole thing turns into x equals a positive 5 plus or minus the square root of 49, the whole thing over 2 times 3 is 6. What is square root of 49? It is 7. So now we're going to get two solutions. The first one is 5 plus 7 all over 6. Solution number 2 is 5 minus 7 all over 6. Okay, what is 5 plus 7? 12. 12 divided by 6 is
2.
2. Okay, what about 5 minus 7? Negative 2. Okay, now we're in a little bit of trouble here because the 6 is bigger, but we can reduce this fraction. What's negative 2 divided by 2? Negative 1. What's 6 divided by 2? 3. So if I divide out their largest common factor, which is 2, I can reduce that fraction. Or you can make your calculator do it. You do negative 2 divided by 6, math, enter, enter, and it'll give you negative 1/3. All right, so now we know what to put in curly brackets. It's x equals our negative 1/3 and the positive 2, and we're done. All right, we're going to do one more and then I'm going to turn you loose. Okay, so this one is a little special. Do you see that I not only have a little extra constant over here, I also have an x term? So do I have anything to combine that with if I look at the left side?
No, does not become the b.
Yeah, it's going to be the b, and it's going to be in the middle. It's not going to be the beginning or the end. It's going to be right smack in the middle. So I'm going to have 4x squared minus 8x. Okay. Now when I subtract away the 3, I'm going to have a negative 3 and a positive 7, which make
4.
a 4. Okay, you could have taken a whole bunch of steps to do that, but if you do it strategically like that, you can do it in like one. Okay, what does the little blurb say? Remember to check for a GCF. So, in all of our other methods, we have to divide out the GCF, right? The thing about the quadratic formula is that, strictly speaking, you don't have to divide it out. But if you leave the GCF in there, your numbers are going to be bigger. And if you multiply a big number with a big number, you're going to get really big numbers. You know what I'm saying? So if you don't divide out the GCF, you're going to have to get big numbers. You're going to have to do more simplifying and reducing at the end. So if you can remember to divide it out early, you save yourself effort at the end and you'll make fewer mistakes. Does everybody understand why I like to get rid of it? Okay, so I'm going to divide by the 4 on both sides. That way it's just consistent with all of our other methods too. We just get rid of it at the beginning and we don't even have to think about it. X squared minus 2x plus 1 is 0. Okay, I want you to identify your A, B, and C, and I want you to plug them into your formula. Really quick, what's the A, B, and C?
A1, B2, C3.
What kind of 2 on the B?
Oh, a negative 2.
Okay. Okay, does anyone have it plugged in correctly? Anyone?
I think I do.
Okay, you want to read it out?
X equals negative 2 plus or minus the big square root sign. Negative 2 squared minus 4 parentheses 1 parentheses 3.
Okay, it's almost perfect. Okay, and did you do the whole thing over 2A? Okay, I see one little baby problem.
You're gonna make
If my b is already negative, when I do the opposite, what is it going to be? Plus. So it should be a positive 2. Otherwise, everything I heard was right. Okay, so when you put this in your calculator, would you do that now? What do you get? You should get 0. X equals 2 plus or minus, oh my goodness, 2 plus or minus the square root of 0, the whole thing over 2. Okay, ask your calculator what the square root of 0 is. Okay. So one of your solutions is 2 plus 0 over 2, and the other one is 2 minus 0 over 2.
1 and 1.
Yeah, and they both simplify to 1, right? Because this is like, we don't need it. It's still 2 over 2. So it's x equals 1. Oops, I don't know why that was random parenthesis. Questions? Okay.